Okay, so welcome back to another video with ENGR. Struggle. Oop. See, struggling every moment. So, let's solve this problem. So for this, we have the slender bar, which is this one or this one, and that's the mass is 2 kilograms and is freely like pivoted, so it can move within that distance. And I just drew a free body diagram with respects to x and y, and we have this, and we also need to treat it as a perpendicular member. So since that's perpendicular, we have f sub k equals to this, and we can also use this as mg and capital MG, which we can combine it such as this. And we also have theta equals to 30 degrees, and this part, okay, it equals to 0.40. So it sounds like we pretty much have most of the things that were provided to us, and we would need to take the moments of O equals to 0, use some statics using the free body diagram that we drew over here. So that gives us this A, which is which we're trying to calculate the acceleration in translation of like a down inclined member, which is mg. So for that, we need to use the frame plus the bar as one rigid body. I mean, not a rigid body, but just like as a body. So this can move, but we would need to find the total, which would equals to capital M plus M, which is a small m, and those two would be 2 and 10. So that would be just 12 kilograms. And then for the normal force, we have N equals to capital M plus M times G cosine theta. And for theta, we know that's 30. Cosine G is gravity, 9.81 meters per second squared. I'm not going to put that. And this, we know we got it from top here, which is 12. Should be pretty straightforward. I love these problems that are straightforward, but sometimes, I mean, the professor just makes it hard so we can learn, but sometimes they just go out of their way to make it extremely hard just for no freaking reason, just to make students' life hard. I mean, come on, don't teach us like whatever the mechanical engineers learn. Just, I always wish that dynamics were 2 separate classes for mechanical engineers and then for civil. Like, why the hell would we even need gears? I mean, yeah, for bridges that lift like up and down, but what is the chance of that we could do? I don't know, 0.5, 5%, 0.005, yeah. And then we have the force K, and we also need to do the align. We also need the force equation along the line that's inclined, which is basically this line or this line, and then that's gonna take down the incline as positive. So we have P, which is the force that's acting, plus masses times the gravity sine theta, and again we're gonna use the same theta, which is 30 degrees, minus the f of k, which we have. Should be pretty easy and straightforward. If you don't know how to do this, at this point you're cooked. Learn how to do it or cheat your way out of it. Those are my suggestions. I mean, honestly, it's better to always cheat your way out of it if you can't. you're cooked. If you get caught, you're cooked. So maybe just practice, practice, practice. But don't fail the class. Even if you can cheat, that's better. But don't try to fail it. Minus 40.78 equals 58.86. P equals to 40.8 kilonewtons. These problems pretty easy, just statics problems, but a little bit dynamics. This one is rigid. It's a non-moving part, so I mean it is moving, but like you also have to kind of calculate the fraction. I mean it's dynamics but statics mixed. So just a little bit of statics on, I wouldn't say on steroids, on protein powder. So yeah, that was it. Take care.